Hello everyone, my name is Christina Maher and I will be discussing the characteristics of three maps. These are the three maps which I will be discussing. The first map is a map of Antarctica. The second is a cropped map from a published geological survey map. And the third is a map of Canada showing population change. First, we will look at the scale characteristics of Map 1. Map 1 provides an example of both a small and large scale map. The view of the whole continent is a small scale map shown by the large area with little detail, as well as the scale being 1 to 68 million. The peninsula view in the bottom left shows a large scale map with a smaller area and more detail. Next is the projection characteristics of Map 1. This map is an azimuthal equal area projection which has the projection surface tangent with the globe. This type of projection preserves area, size, and true direction, but does not preserve shape, causing distortion. Last for Map 1 is the coordinate system. Here we see the use of latitude and longitude, which are part of the spherical coordinate system. Now we will move on to the characteristics of Map 2. The scale characteristics of Map 2 include a large scale map with a scale of 1 to 24,000. This is an example due to the small area with great detail, including topographic features, roadways, and borders. Next, we move on to the projection characteristics of Map 2. Map 2 is a polyconic projection, meaning many cones. This projection is created by lining up an infinite number of cones along the central meridian. This causes the meridians to be curved instead of linear. If you are along the central meridian, shape, area, and direction will be preserved. However, as you move away from the central meridian, distortion occurs for all shape, area, and direction. Last, we move on to the coordinate systems for Map 2. Here we see the UTM coordinate system, the Pennsylvania coordinate system, and NAD 27. When using the UTM coordinate system, we see distortion as the area of interest gets closer to the North Pole. However, scale distortions are avoided due to the nature of the UTM zones. The Pennsylvania coordinate system is for defining and stating the positions or locations on the surface of the Earth within the Commonwealth of Pennsylvania, which is split into North and South zones. The use of NAD 27 can be controversial in that updated versions may have different benchmark points. Therefore, we can expect from this graph to have the positioning of some features to be inaccurate in comparison with later versions of NAD. Last, we move on to the scale characteristics of Map 3. This map of Canada is an example of a small scale map due to the large area with little detail. The only information provided is population change from 2006 to 2011, as well as the province borders of Canada. It is also shown as a small scale map because of the 1 to 24.2 million scale. Moving on to the projection characteristics of Map 3, we see a conformal projection of Canada, which preserves shape and angle, but size and area are distorted. Finally, we have the coordinate system characteristics of Map 3. Here we see an example of the State Plane Coordinate System, or SPC. Even though this example is a map of Canada, as you can see, the zones are defined based on their political boundaries within Canada. Thank you for listening.